Welcome to Brain Vision.
Using the information given in part A, let's calculate the moles of solvent contained in the gas phase. We're going to calculate the enthalpy of vaporization from the data at 25 and 45 degrees Celsius, 2.30 T, 3 RT T prime over T prime minus T log of P prime over P. And substitute our values in 2.303, 8.314 joules per mole Kelvin. Initial temperature 25 degrees Celsius or 298 Kelvin. T prime is 45 degrees Celsius or 318 Kelvin. 318 Kelvin minus 298 Kelvin. Log P prime is 200 millimeters of mercury, and P is 50 millimeters of mercury. Solving here, we get 54,621 joules per mole. And now we can calculate the vapor pressure from the enthalpy of vaporization and the data at 25. So log of P prime over P prime over P is equal to delta H vaporization T prime minus T over 2.303 RT T prime. Log of P prime is our unknown, 50 millimeters of mercury. Delta H vaporization is 5,621 joules per mole. T prime is now 35 degrees 35 degrees Celsius or 308 Kelvin minus 298 Kelvin, 25 degrees Celsius over 2.303, 8.314 joules per mole Kelvin. T is 298, T prime is 308, and solving this for the pressure P prime, we find that this is equal to 102.33 millimeters of mercury. Now we can plug this into our ideal gas equation. The number of moles is equal to PV over RT, and so we have 102.33 millimeters of mercury. The volume is 150 milliliters or 0.150 liters. Ideal gas constant is 760 millimeters of mercury times 0.08206 liters atmospheres per mole Kelvin, and this is 760 meters per 1 atmosphere. That's our conversion there. And temperature is 308 Kelvin, 35 degrees Celsius. Solving this for numbers of moles, we find that this is equal to 7.98 times 10 to the negative 4 moles. So this is the moles of solvent present in this liquid and vapor states at in the gas phase at 35 degrees Celsius. For part B, stating the assumptions made, we're going to assume that the species does not dimerize. Because if dimerization occurs, the number of moles will be halved, and the vapor pressure will be less.